could take a simple idea, a sketch on the back of a napkin, and turn it into a fully realized, performance-tested supercar design in just a few seconds? It sounds like something out of a sci-fi movie, but it's happening right now. Today, we're going to dive into how generative AI is just completely smashing the old, slow traditions of engineering and kicking off a brand new era of creation. So, to really get why this is such a massive deal, we first have to look at the problem, right? For years, the traditional way of designing things in engineering has been a huge bottleneck. Honestly, it's a relic from a different time, and it's really struggling to keep up with today's demand for faster, more complex innovation. And look, this has nothing to do with a lack of skill. We're talking about brilliant engineers stuck with a process that is, at its core, just incredibly time-consuming, labor-intensive, and frankly, pretty inefficient. It's a system that forces you through slow, painful iterations for every single tiny refinement, and that just bogs down creativity and kills progress. Now, take a look at this workflow. It's a straight line, right? You start with a sketch, you build a super complex 3D model, you run a bunch of physics simulations, you tweak the design, you test it in a real wind tunnel, which is crazy expensive, and only then do you get to manufacturing. Every single one of these steps takes a ton of manual work and resources. And the worst part? If you find a problem late in the game, you might have to go all the way back to the beginning. It's brutal. But what if you could just break that chain? What if you could shatter that linear process? Well, this is where generative AI storms in. It's not just a small improvement. It's a whole new engine for creation that's about to completely rewrite the rulebook for design and engineering. Okay, but it's crucial to understand that not all generative AI is the same, not by a long shot. For a while, we had these models called GANs. They were promising, but honestly pretty unstable and kind of limited. The real game changer, the big breakthrough, came with what are called diffusion models. These are the absolute powerhouses behind the tools you've heard of, like DALL-E and Stable Diffusion, and they deliver incredible stability and way better results. So how in the world do they work? It's a really cool two-step process. First, you teach the AI by doing the exact opposite of what you want. You take a clean image, and you just systematically add random noise to it, little by little, until the original picture is completely gone. You're basically teaching the AI what pure static looks like and showing it every single step it took to get there. And this is where the magic happens. Once the AI has perfectly learned how to destroy an image with noise, it can then learn how to reverse that exact process. So now it can start with a screen full of complete randomness and, step by step, take the noise away until it generates a perfectly clean, super detailed, and totally new image. It's literally creating something incredible out of nothing. Okay, so that's the theory. Cool, right? But now let's see how this all comes together in a mind-blowing, real-world application. How does this tech actually accelerate the design of something as complex as a car? This is the new Playbook. An engineer starts with a basic 2D sketch, just the core shape. Then they guide the AI with a simple text prompt, just describing the vibe, the style, and the intent of the design they're going for. And this quote from the research, this is absolutely key. The AI isn't just making a cool picture that ignores the sketch. No way. It's generating all these amazing aesthetic variations while staying true to the original structure. It actually understands the engineering intent behind the drawing. And just look at the creative freedom this unleashes. I mean, with the same base sketch, a designer can instantly explore dozens of totally different styles. You want to see it as a rugged off-roader? Done. How about a minimalist electric concept car? Or maybe a steampunk-inspired classic? The AI just generates these options in the blink of an eye. And here's the absolute kicker. These aren't just pretty pictures. The system is so advanced that it can actually check a database of thousands of high-fidelity simulations in real time. So that means it can pull up aerodynamic performance data for the brand new design it just created. It instantly closes the gap between early-stage art and late-stage engineering. It's unbelievable. So yeah, this isn't just a cool tech demo. The impact this has on productivity and efficiency is just staggering. When we look at the numbers, you start to see the true scale of this revolution. 100 times faster. Yeah, you heard that right. Research shows that things like structural design, which used to take maybe 1,000 slow iterations, can now be accelerated by a factor of up to 100. That is a genuine quantum leap in speed. And of course, when you move that fast, the money follows. Case studies are showing that by using AI-enabled engineering, companies can cut project investment by more than half compared to the old ways. Now, you might be thinking, okay, faster and cheaper. That must mean lower quality, right? You're cutting corners. But it's the exact opposite. Because the AI lets you do so much more testing and optimization right at the beginning, companies are seeing defects in the final product drop by around 40%. It's better, faster, and cheaper, the whole package. This change is so fundamental that it goes way beyond just designing cool cars. AI is quickly becoming an essential co-pilot for engineers across every single industry you can think of. I mean, we're seeing AI generate instructions for factory robots on the fly. We're seeing it predict machine failures before they even happen, saving companies millions in downtime. It's even generating optimized architectural plans for buildings. The entire field is shifting from just selling products to delivering smart, integrated systems all powered by AI. And that really brings us to the future of all this. Engineering isn't about isolated parts anymore. It's about orchestrating these huge, interconnected systems. And AI, well, AI is the conductor's baton that makes it all possible. It allows for a level of integration and collaboration we've just never seen before. So the debate really isn't about if AI is coming for engineering jobs. It's already here, and it's transforming the very nature of the work. And that leaves us with a critical question for everyone in this field. Will you be the engineer who uses AI, or will you be the one it replaces? The future of innovation really depends on that answer.